When I say synthetic division, do you have any idea what I'm talking about? We're in problem number 5 now.
I forget how, I remember doing it, I forget how you set it up.
We're on the back of page 18, the section that says synthetic division practice. Okay, synthetic division practice.
I know what you're talking about.
We have a need, and we're getting ready to do it, in the very next problem we try to graph. We need to be able to divide polynomials. So we're not graphing this one. This is just practice to refresh our memories about how we do synthetic division. We can do polynomial long division, which is where you set up and do the huge long division like you did back in 3rd grade. We don't want to do that if we can help it. We can, it's a possibility, but it's so much easier to use what's called synthetic division. And what we do when we synthetically divide is, we put a number out here in a box. That look familiar?
Yeah.
Yep. And the number that goes out in the box is the same number that if you were graphing, you would put a dot on the x-axis. So in other words, when you look at this parentheses, you put a dot at -3, right? So when I look at this parentheses right here, in the box goes 2. Wherever you would have put the dot, if you were graphing that parentheses, that's what goes in the box. And then all of these coefficients, the numbers, get written out here. But I put a tricky one in, because when you do synthetic division, every power has to be represented. So I see an x to the 4th, so there's the 2 that represents the x to the 4th term. But what's missing in here?
3.
So I got to put a 0 for the x cubed. There is no x cubed term, so I put a 0. There's a 3x squared, a -9x, and then a 1 on the end. So I put all of the coefficients in this row of numbers. If something is missing, I have to hold its spot with a 0. So this is x to the 4th, x to the 3rd, x to the squared, x to the 1st, and x to the 0s, technically, just the number. Okay, got it? So then you're on notebook paper. Oh, no, you're not. You're on my paper, but it has lines. Good. Because we want to leave a line. Draw a line straight across, but there's a space in here. You're going to write some numbers in here. And this one comes straight down. So whatever the first number is that you wrote, it comes straight down. Does this look familiar to anybody? Kind of remember this a little bit? You did it. Y'all did it. Okay, now we multiply this number times this number, and we write the answer here. So 2 times 2 is 4. Now add. Then start over. 2 times 8, or 2 times 4 is 8. Add. 2 times 11 is 22. Add. 2 times 13 is 26. Add. Now we're done. The problem is finished. So how do I write my answer? Does anyone remember that?
Just drop the X's down.
What?
You just drop the X's down.
Exactly. This becomes your new row of numbers. But the powers are all decreased by 1, as James said. So instead of being 2x to the 4th, it's now going to be 2x to the 3rd. Plus 4x to the 2nd, plus 11x, plus 13. Wait a minute. What do I do with that? What's that? That's the remainder. Remember, this was a division problem. And when you do division, what doesn't always happen, but what usually happens? You have a remainder. So we have a remainder, and we write it like this. Back when you were a little kid, you did your division. Let's say you took 4 into 91. All right, so you said 2 and 8 and 11 and 2. Okay, when you were a little kid, you said remainder 3. We don't do that anymore. Now we know that means 3/4. 3/4. So that's how we do it. We put 27 over the thing we divided by, which is x minus 2. All right, let's try the next one. Synthetic division. What are you going to put out here in the box for number -1? Then across the top, 3, -7, 9, and 1. Now, do I have any zeros in this problem? No, because every power is there. 3, 2, 1, 0. It goes right down the row. Every power, every exponent is there. So then we draw a line across here and drop the first number straight down. Then -1 times 3.
-3.
Add.
-10.
-1 times -10. Add. -1 times 19. Add. Everybody okay with the process? Now we write our answer. What's our answer? 3x squared. Remember, it goes down 1. This was a cube to start with. So it goes down 1. So it's 3x squared minus 10x plus 19.
Plus 18 over x.
And then your remainder is -18 over what I divide by x plus 1.
Yep.
Okay, will you try the last one on your own? Then we're going to go back and I'm going to show you what you're going to use this for. How'd I do? Does that match yours? Anybody have a question about C? James?
So for your remainder, do you always have to put plus whatever it is over that, like, or can you just put it off to the side?
No, you should make it as part of this, as the part of the thing, yeah. Now, truthfully, James, there aren't going to be many times when we're actually going to be interested in this whole thing. The remainder is actually going to become the fascinating part for us here in a minute, but this is the way you would write the answer to the division problem. All right, so everybody's good with all those numbers. You remember how to do synthetic division. So if I were to give a little pop quiz sometime over synthetic division, we'd all do great.
Why not?
Magnus, why not? What's confusing you about it?
Like, it's just remembering the process.
Yeah, well, that's what you have to do. Yep, you got to remember the process. So I encourage you to practice. There are division problems in your book. You could certainly just recopy these and redo them since you know what the answers are. But yeah, we got to remember the process. Okay, so now I am back on the back of page 17, problem number 4A, and it says factor and sketch this. Now those are the exact same directions, that we had in the last section of graphing that we did. And so we just factored by grouping and everything worked out great. Oh, this problem. could we group? Oh, yeah. But look what's gonna happen. If we take an x squared out of the first two and a -1 out of the second two, what doesn't happen that has to happen? They don't match. And if they don't match, you've either made a mistake, which I didn't, or it doesn't factor by grouping. So, oh my gosh, what do we do if it doesn't factor by grouping? Jalen is exactly right. We use synthetic division. So here's what I want you to do. I want you to think about, okay, you're trying to come up with your parentheses, right? So I just wonder if x minus 1 is a factor. Is x minus 1 one of the factors of this? Well, how could I tell? If I did the division and it is a factor, what will happen in this spot right here? There won't be a remainder. So let's try it. Let's do synthetic division with this as a factor. So we'll put a 1 out here, right? And then our 1, 2, -5, -6. Now, I know what you're thinking. You're thinking, Mrs. Ford, why in the heck, where did this x minus 1 come from? It's a guess. Because that's what we have to do. We have to guess. There isn't a magic formula. We just say, okay, I wonder if this is a factor. Well, let's see if it is. Okay, did I make a mistake?
Yep.
I did?
No.
Oh, no.
I didn't make a mistake, but I made a bad guess, right? I made a bad guess. This is not a factor because the remainder came out to be -8. And if you are a factor, you don't have a remainder. When I say 5 is a factor of 15, that means it divides in evenly, right? 5 is not a factor of 12 because it has a remainder. Okay, so this is not a factor. So let's guess x plus 1. Now, what will that change? That will make all this different, and it'll make that a -1. It worked. So that means that one of my factors is x plus 1. Did everybody follow that? Did everybody get a remainder of 0 down here?
Yeah.
So that means one of my factors is x plus 1. It also means that I have an x squared plus an x minus a 6. Now, can I factor that?
Yeah.
I can. How does that factor? X.
X plus. X minus. X plus 3. X plus 3, X minus 2.
X plus 3, x minus 2?
Yes.
So there's the factor I guessed, which was x plus 1. And then there are these two others I figured out after I did the division. So now I have all 3 of my factors. Remember, your job is to sketch it. Now you have all 3 of your factors, so we can do that. So we have -1, -3, and 2. How do I know it looks like that? Is x cubed? Nothing bounces, dots have to be connected, everything's passed through, there it is. Done. Now there's only one piece of that process that should have you concerned. What is the one piece of it that is a potential issue? That whole guessing thing, right? That whole guessing thing. I got lucky, and I got it on my second guess. And by the way, I always start with 1 and -1 because they are easy numbers to work with. They don't always work though. That is a tricky part. There isn't an absolute rule that I can say, here's how you figure out which numbers to guess. But there is kind of a hint that narrows things down for you. So before we do our next example, we're going to talk about the possible rational root rule. I call them the PRRs. So over to the side of the problem, you can see I even had written PRR, and you probably wondered, what does that mean? Well, it means what are the possible rational roots? Now, I've already done this problem, so there's no point in me doing this. The PRRs are something you figure out ahead of time because that's your pool of guessable numbers. So I just was randomly guessing, but this is going to give us our pool of guessable numbers. It is the factors of the constant term divided by the factors of the leading coefficient. So in our problem, this number is the constant term. By constant, we mean the one with no x. The leading coefficient is the number on the biggest power. So again, being a Catholic school educator, I try to have biblical references, and you know that passage that says, the least shall be first. Well, the last over the first. The last over the first. That's how I remember it. It's last over first. Now, what are the factors of 6? Because I want the factors of that number. So the factors of 6 would be plus or minus 6, 3, 2, and 1. Those are the numbers that divide into 6. And we always use plus or minus. Always plus or minus. Huh? This is P's and Q's. So those of you that were in academic last year probably talked about it as P's and Q's. That's exactly what it is. I don't use that vocabulary, but yes, they do. What are the factors of the leading coefficient? 1? So your list of guesses has been narrowed down to this. So when I was guessing a factor, I would not have guessed x plus 5 because 5 isn't in my list. Now, could I have guessed x plus 2? X plus 3? Yeah. This gives you which numbers to guess from. It doesn't tell you exactly which one to use, but at least it narrows it down for you.
So then only one of them worked?
No. Actually, look which ones ultimately worked. -3, -1, and 2 were the ones that ultimately worked, right? So your answers are going to come from that list. Always. You only need to guess one of them, because once you've guessed one, James, then the other ones you can get from your quadratic here. Do you see what I'm saying? If you wanted to keep guessing, with that, you could, but that would be so inefficient. So I guessed x plus 1. I could have guessed x plus 3, and I could have guessed x minus 2, and any of those would have worked. All right. Well, what time is it? Oh, shoot! We don't have time to do another one, do we? Darn it. Right. Okay, now here's the good news, though. I will see you tomorrow, and we will